Hello students, welcome to Power Tutorials. So let's continue our live sessions. So today we'll have the live session of Science Class 10 Sample Paper Solution, and today we're going to cover Section C of Physics, and that too we're going to cover the 5 marks questions. Okay, so let me just give me 2 minutes. I'll just check whether audio, video, everything is fine. Just 2 minutes. So in the previous video, that is on the Wednesday, we have covered MCQ questions as well as few 2-mark questions of electricity chapter. So today our main focus is on covering 5-mark questions, because in the sample paper I have one 5-mark question of from electricity chapter A or B. At the same time, for visually impaired, it is also mentioned another A or B question. So total 4 questions we're going to cover today, each are of 5 marks. Okay, so I could see that audio is fine. So now let's start with the video. So if whoever is watching this video the first time, if you want the solution for other parts like till section A, section B MCQs, as well as the other questions which are there in for electricity chapter, you can refer my previous videos. Those I have kept in the live section of my video channel. Okay, now let's start with the 39th question. So for 39th question, we have total 4. I can say, like, for normal students it is mentioned A or B, and for visually impaired it is mentioned A or B. So we're going to cover all 4 questions in detail in this part, along with the concepts which are as there related to these questions. Okay, let's see the first one. Attempt either option A or B, it is clearly mentioned as I told. So when you have any such questions like which you have A or B, always prefer the one which you have much confidence. And if you have time, if you want to solve second question, you can solve it, but whichever you have answered first will be considered for marking. Okay, let's see the question. You can see we have one like voltage source, a voltmeter connected parallel to it, and then we have one resistor here which is 100 ohms, and then we have two resistors 25 and 25 in parallel, and we have another voltmeter V2 here. Okay, so for circuit I will repeat, these are voltmeters connected in parallel, and we have one voltage source here. The cell represents the voltage source, and we have total 3 resistors, one is in series and 2 are in parallel. The arrangement of resistors shown in the figure is connected to a battery. Okay, as I told you, this is a voltage source, which is nothing but battery. The power dissipation in 100 ohms resistor is 81 watt. So for 100 ohm resistor, they have provided you the power rating. Power is how much? 81 watt. What they are asking? Find the current in the circuit. So for this, so we have power is 81 watt, current we need to find, and resistor value we have, which is 100 ohms. So total for power we have total 3 formulas, which are VI, V square by R, or I square R. So which parameters we have here? We want I, and we have R, and we have W. So sorry, P, which for this we have to use I square R formula. So power is equal to I square R. So from this I can get the I formula as root of P by R. So let's substitute the values. Power is 81 and R value is 100. So which is nothing but square root of 81 is 9 and square root of 100 is 10. So 9 by 10. So I got the current value as 0.9 ampere. Okay, that is for 1 mark. Reading in the voltmeter V2. Okay, so this 3 questions is for 5 marks, so definitely this current rating or the current value which you found is should carry definitely of 2 marks. Okay, this is one. Now let's solve the second parts. Second, what we need to get? The reading in the voltmeter V2. V2 is here. Okay, so this voltage we need to find. Okay, so for this what I will do is I will reduce or else simplify this circuit so that this forms a single voltage source or a single resistance. Then I can find the current flowing through it, because this same current, this current will be flown through this circuit as well. Okay, so the current, how much we got? We got the current rating as 0.9 ampere. So this current will again go and it will redistribute into 2. So the same, instead of getting redistributing and again calculating the voltage, what I will do is I will simply change the circuit to this way. I have a voltage source, I have 100 amps, sorry 100 ohms. Now I will reduce the other two resistors to single resistor so that this becomes V2, and here we have V1. So now what is the parallel combination of R25 and 25? So parallel combination of 25 and 25. I will write it separately. 25, 25. For parallel combination, what is the effective resistance? 1 by R is equal to 1 by 25 plus 1 by 25. So 1 by R is equal to 2 by 25. From here I can say the effective resistance R value is 12.5 ohms. So this value is how much? 12.5. So the same current 0.9 ampere will be flown to this resistance as well as through this resistor, because these are connected in series. Now the V2 is nothing but the voltage across this 12.5 resistor. So V2 is equal to R into current. R is 12.5, current is 0.9. So let's multiply this to 125. Excuse me. So let's solve this. 125 into 9, 5 9 45, 4 and 2 are 18, 22, and 1 is 9, 10, 11. So which we got 11.25 is the voltage across V2. Okay, what is the next question? The reading of the voltmeter V1. V1 they are asking. V1 is here. So V1 is nothing but the voltage of this one plus this one, because V1 is parallel to this entire circuit. So this is 2. So for V1 is nothing but voltage across 100 ohms plus V2. What is voltage across 100 ohms? Resistance is known, which is 100. Current we know, which is 0.9, plus this voltage we already got, which is 11.25. 100 into 0.9 is 90. So 90 plus 11.25, which is 101.25 volts is the voltage across V1. Okay, so first 3 parts have been solved. So this is very important, because this type of questions will be coming for sure in your board exam. It might not be 5 marks, but it can come at least for 3 to 4 marks at least. Okay, so we have a parallel combination type of question. For parallel combination, what is effective resistance? 1 by R is equal to 1 by R1 plus 1 by R2. For series connection, current is same, and for parallel connection, voltage is same. So this we need to remember. Okay, now let's move to the B part. So B part is little interesting, because we need to check the question properly and then you have to solve it, because if you miss a small point, then definitely our question will go wrong. Okay, so let's understand the question properly first and then we'll go with the solution. Hope you guys are able to see the question properly. So what is the question? Here you can see we have one voltage source which is 240 volts and we have one switch S1. We have two another elements. We have switch S2 here and then you have another element switch S3 here. Okay, an electric heater consists of three similar heating elements A, B and C. So this all circuit is related to an electrical heating element. Okay, and it has three elements A, B and C. Each heating element is rated 1.2 kilowatt to 240 volts. So it is saying power rating is 1.2 kilowatt and voltage 240 volts. Okay. So it is respectively provided current in the circuit. The circuit is connected to a supply. Supply they have provided is 240 volts. Okay, fine. Calculate the resistance of heating element. So the first one, to calculate the resistance, we have power, we have voltage, we need to find resistance. So if you remember the previous question, I had told you total. For power, we have three formulas which are VI, V square by R and I square R. Now we have voltage, now we have power, we need to find resistance. So for this reason, I am using the second formula which is V square by R. So 1.2 kilowatt is 240 square by R. So R value is 240 into 240 by 1.2 is not watt, it is kilowatt. So 1.2 into 10 power 3. So this will become 12 into 100. Instead of 12 into 1000, I wrote 12 into 100. So these two zeros gets cancelled out. 2 ones, 12 twos, 12 twos are 24. So the R value is 48 ohms. So the resistor for each heating element is 48 ohms. Okay. So now this whole circuit can be written as differently. Okay, before that let's see. Calculate the current in each resistor when only S1 and S3 are closed. S1 and S3 are closed, S2 is open. So I'll write the circuit first. So now we have a 240 volt supply. S1 is closed, so we have one heating element which is 48 ohms. S2 is open, so this also will be there, which is 48 ohms. And then we have S3 is closed, so this resistance is again 48 ohms. So this is the new circuit with respect to second condition. Okay, so this is open whereas these two are closed, this one and this one. Okay, this one is closed and this one is closed, this is open. Now what we need to find? Current in each resistor. So this is A, B, C. Okay, so as per the circuit, this is A, this is B, this is C. Now we need to find the current across each heating element. Okay, so for this we have to use series and parallel circuit combinations. So before that I will make it easy. So what I will say is, instead of solving the entire circuit, we'll just change the middle part. Okay, now this becomes 240. What is the series combination of two resistors? You have to just add it. So it is 48 plus 48, which is 96, and the third is 48. Now the voltage is, explain the last sum once again. Okay, so hi, can I spell your name as Raji? Is it correct? Okay, so let me explain the first question once again. So the first question, A part, is they're saying that we have one voltage source here, we have one resistor which is 100 ohms, and this is connected to two resistors which are connected in parallel, which is 25 and 25. Okay, now the first question, the power dissipation in 100 ohms is 81, Rajani, sir. Okay. Yes, Rajani. So I'm just explaining the first part once again. So if you have any doubts, you can let me know. So I'll repeat that question once again. Okay. So as I mentioned, the power rating that I mentioned for this question, the 100 ohms is 81 watt, and the resistor is 100 ohms. So simply you have to use, for power formula we have total three, which are VI, V square by R, and I square R. So based upon our requirement, we have to use which formula based upon the need. So here we have power, and here, sorry, let's go to first one. So here we have resistor value and we have power value, and we need to find current. So that's the reason for this we have to use 100 is the ohms, resistor is this one. So simply V power is equal to I square R. If I use, I will get the value of current. Okay, so P is equal to I square R. I value will become root P by R, which is 81 by 100, which becomes 0.9. Okay, and then we have the second part where we have two resistors in parallel. So 25-25 parallel combination will become 12.5. So based on that we have the current value. So just same current will flow through here. So simply 0.9 into 12.5 will give you the voltage across 12.5 ohms. Okay. Then we got V1 value. V1 value is voltage across 100 ohm resistor plus V2. So it is 100 into 0.9 plus 11.25. So the final value will become 11.25 ohms. Okay. Let's move to the B part. So the B part is the question. We have total three switches, S1, S2 and S3. In the first case what they are asking, they provided us same way power rating, and they are asking to find the resistance the same way. But here voltage is provided and power rating is provided. So that's why I have used V square by R formula, and then I have found the resistance value. And next part, second part, they are saying S1 and S3 are closed. So now this circuit can be changed to this way, such that we have 240 volts, 96 ohms, and the last one is 48 ohms, because 48 and 48 are in series, it becomes 96. Okay, now we have voltage, and then we need to find the current values. So we have to simply use the Ohm's law, which is V is equal to IR. So 240 is equal to 96 into I. So this current is for IA and IB, both are in series, so same current will flow through IA and IB. So IA is equal to IB is equal to 240 by 96. So 48 2s and 48 5s, this one. So this becomes 2.5 amperes. Okay, what about IC? IC, here the voltage is 240, the resistance is 48. So simply 24 2s and 48. So this becomes 5 amperes. So the current flowing through IA is equal to flowing through IB, because it is both are in series, which is 2.5 amperes, and the current flowing through the third circuit element, which is C, is 5 amperes. Okay, so this becomes IA is 2.5, IB 2.5, and IC is 5. Okay, what about third one? Calculate the power dissipated across A when S1, S2 and S3 are closed. So this is very interesting question, because we should not blindly follow VA or V square bar kind of methods. We have to first understand what is the type of current flowing through it and what is the circuit as of now, if S1, S2, S3 are closed. So now the circuit changes to, we have a voltage source, S1 is closed, okay, and here 48 and here 48. These are ohms, which we found from the first part. And then we have another 48, and here if you notice, this switch is also closed and third switch also closed. So if any circuit, if you find something like this, first point and the ending point are shorted, we call it a short circuit. If this is short, what will happen is no current will flow through this part. The current will directly flow through this short element. So for this I am going to explain in this way. We have a resistor like this, suppose A and B, and we have a voltage source somewhere like this. Okay, for suppose what I will do is, I will short this element. If I short this element, what will happen is, I have connecting a wire something like this, where A and B are same. If I just connect a wire like this, what will happen? The voltage across A and the voltage across B will be same. If any circuit, if you have something like this, then what will happen is no current will flow through this element, because the current will always check which path is easier for me to travel. So here if you notice, the resistance is something like it is blocking something, whereas here it is a direct wire, so the current will directly flow through this wire, it will not flow through this point. This is as per theory, but in practical, minute amount of current can flow, but it is very negligible when compared to the current flowing through this wire. Okay, so here also this circuit is very important as I'm talking, because here there is a short circuit kind of concept. Okay, so here we are sorting this point or closing this switch. So if you close the switch, what happened? It became a short circuit. So due to this, the current will not flow through this resistor. It will only flow through this 48 element and it will go here. Now this circuit I can rewrite as something like this. You have one 48, another 48, and you have a voltage source like this. So simply we don't have circuit element B here. We have only two circuit elements now, which are A and C. Okay, hope you understood. Now let's see what they are asking. Calculate the power dissipated across here. So simply they are asking to get the power value for this resistor. Okay, so this we can solve using two formulas, either V square by R or I square R. I will show you both the formulas. I will prove it that both the values are correct. Okay, so for this we need to know the voltage across this resistor. Voltage across resistor we already know, which is 240. So 240 into 240 by the resistor is 48. So 24 2s, 24 10s, 22 1s, 2 5s. So 240 into 5 is the power rating as per V square by R formula. We'll also explain using I square R formula also. Okay, so 24 into 5, 4 4 is 20, 2 5 is 10, 11 12, 5 4 is 22, 5 2 is 11 12 is correct, and 0. So 1200 watt or 1.2 kilowatt should be the answer. Same I will prove it using I square R formula also. I will prove it that both the values are correct. Okay, so using I square by R. So first we need to get what is the current flowing through the resistor, and that current will be the current flowing through this, and using that formula I can solve it. So if you notice, these two are in parallel, so the same voltage will be there at 4. So first I will find the current flowing through this A circuit. So it is 240 by 48. So which is 24 2s, 24 10s, so 2 1s, 2 5s. So the current flowing is how much? 5 amperes. Now using I square R formula, I can prove it. I square is 5 square and R value is 48. So which is 25 into 48. So let's solve this. I'm solving here 25 into 48, but always make sure to do the calculation right side. Now I don't have place at the right side, just when solving it here. 48 into 25, 5 4 40. 5 is 44, 5 4 is 20, 24, 2 is 16, 1, 2 4 is 8, 9. So now you can find it here. The same value I got using the second formula also. 1200 watt or 1.2 kilowatt. So that's why I'm saying formula is correct. But how we are following this and how we are using this, that is important, because this is the voltage across the resistor. This is the current flowing through the resistor. If you calculate this current, then definitely your answer will be wrong, because this current is important when you are following this formula, and this formula is current when you are following the voltage across the circuit element. Okay, now let's move to the second, because they have mentioned for visually impaired we have to solve another two questions, either A or B. So now we are going to solve those two questions now. So here also they have provided A or B, so either one you have to solve it. If you want to solve second, you can solve it, but that will not be considering for marking. Either it is correct or wrong, you will not get any mark. So let's first understand the question. A, we have again two questions, so two subparts. The A part, explain why in household circuits only the fuse is connected in series with all the rest of the appliances, but all appliances are connected in parallel to each other. Okay, so the first part is a theory question. I will not write in steps, but I will simply explain how, so that you can write it on your own words. Okay, so the explanation is why fuse is required and why fuse is connected in series. Why fuse is connected in series? Because it is something like this. We have a supply, this is fuse, and then we have appliances which are connected in parallel. So why the fuse is there? Because if any extra currents, like suppose we have an element which can only accept suppose 5 amperes, and we have suppose this element contains accepts 8 amperes. So our fuse should be greater than 13 or somewhere around 14 amperes. So if suppose 15 amperes current is passing, then what will happen? This fuse will break. So if fuse breaks, no current passes through this, so that the both the appliances will be safe. Okay, I will repeat the concept again. So why fuse in series? Fuse in series to protect appliances from high currents. Okay, generally the fuse rating will be 1.2 amp times of the current rating which is there. So if it is greater than if the current is greater than 1.25 times of the actual current, then definitely the fuse will break. If fuse breaks, it breaks at excess current which opens the circuit. So now the same circuit, now it becomes something like this. Okay, this is appliance 1 and this is appliance 2. So both these appliances will be safer. Why? Because this circuit got opened. There is no current flowing through this. So that's the first explanation. And the second, but all appliances are connected in parallel. So what is the reason for the appliances to connect in parallel? So if appliances are connected in parallel, what will happen? The same voltage will be across each element. Okay, so voltage across each appliance will be same. So if suppose any appliance got malfunction, what will happen? This current will go 0, but this current will happen, and this because the same voltage is connected. This circuit might work or does not work, doesn't matter. And I can also see each appliance works or functions independently. So this is very important and important point. So why each appliance is parallel? Why? Because if any appliance got malfunctions, what will happen? The other appliances will not get affected because these are connected independently. And the voltage is connected in parallel, so each appliance will have the same voltage so that they can draw small currents. So why it is in small currents? Because the same voltage is here. So this will have some current, this will have some current, this will have some current. But everything is connected in series for suppose. Then what will happen? Suppose this got malfunction. Then knows it can be open or short. If it is short, then entire voltage will be coming and a high current can flow. If it is open, then this appliance also will go off if one is off. So this way appliances should be connected in parallel because they can work independently, and thus they can get the same voltage, and the current rating can be independent. It can be smaller or lesser, and it will always draw very low currents when compared to the series connection if any malfunction happens. Okay, so hope it explains the first part, theoretical part. Let's solve the second one. In the household circuit, an electric heater of power of 1500 and the fan are connected in parallel to 220 volt supply. Okay, now we have a 220 volt supply, and these are connected in parallel to appliances. So what is there in the appliances? One is 1500 watt and the other is 500 watt. 1500 watt and the second is 500 watt. Okay. A fuse rated is 10 amps is connected in circuit to protect the excessive current. Okay. We have a fuse. I told you it is in connected in series, and this rating is 10 amperes. Okay, every appliance will have a rating. Okay, power rating, current rating, or voltage rating. Calculate the total current drawn by the heater and fan. Okay, so first we need to get I1, I2, that is I of heater and I of fan, and then we need to get the total currents, means IT is nothing but IH plus IF. Calculate the total currents. Okay, so first we need to get the total currents drawn by heater and fan. Okay, they're not adding to sum it, but we can find it and can also sum it as well. Okay, so for heater we have power rating and we have voltage. So which form you have to use? Power is equal to V into I. So I value is nothing but P by V. Power is 1500. V how much? 220. And fan power is 500. Voltage is 220. Okay, we'll get in decimals now. Let's solve the decimal values. 0 0 cancels, 2 11s, 2 25s, 0 0 cancel, 2 11s and 2 75. Okay, we need to get 75 by 11 and 25 by 11. 11 75, 11 6 66, 90, 11 8 88, 20. It is somewhere closer to 2. So write this value as 68.2, sorry, 6.82. 6.82, and this value 11 by 25. 1 2 is 22, 30, 11 3 is 2 is a 20, 22 again, 80, and 11 sevens. It is 22.7. So 2.72. So if I add these two, I'll get 0.4. 8 plus 7 is 15. So I'm getting 9.54 as the value. Just small correction, it is 2.27, not 2.72. Okay. Okay, now 8 plus 2 is 9. 2 plus 7 is 9. 8 plus 2 is 1. So I got the value as 9.09 amperes is the total current, and the fuse rating is 10. So I can see for B part, the total current we got how much? 9.09 amperes. Determine whether the 10 amp fuse is appropriate. Yes, we have to say it is appropriate. Yes, it is appropriate as fuse rating 10 amperes is greater than 9.09 amperes. Hence, this is enough to secure these two elements. Okay. Now let's solve the last question. The B part of this visually impaired, for visually impaired questions, B part. Let's solve this. We had two resistors R1 R2 connected in parallel to 24 voltage source. We have a voltage source 24 volts. We have two resistors in parallel 6. The second resistor is how much? 12 ohms. What they are asking, calculate the total heat generated. Okay, we have time which is 5 minutes. So that let's find the total time when compared to seconds. 5 minutes, so 5 into 60, which is 300 seconds. Because the unit of heat is always in joules. Joules is as per seconds, not for minutes or hours. Okay, calculate the total heat generated. So let's find, first find the, you can also have directly voltage. You can use the voltage formula or current formula, but again, as I told you, both the formulas will be correct if you follow the exact scenario how to find it. Okay, but here as I have parallel voltage, I will directly use the voltage formula. So heat or energy formula is, in this case I'm using V square by RT, because I know the voltage and know the resistance. Okay, so voltage is how much? 24 square. So heat across 6 ohms is 24 square by 6 ohms into time is 300. Same I'll write the second part. Voltage across the second one is 12 ohms resistor. Heat across 12 ohms is 24 into 24 by 12 into 300. 300 is the time here. So 6 4s are 24, 12 2s are 24. So this becomes 24 into 1200. Heat across 12 ohms resistor is 24 into 600. So I'll just find this and this I'll multiply into 2 to get the first one. 24 6 6 4 is 24 2 6 2 is 12 13 14 0 0. So this I can say it as 14,400 joules. So definitely this will be double of it, which is 28,800 joules. About the heat across 6 ohms resistor and the heat across 12 ohms resistor. So what they are asking, total as well. The total heat generated, yes. So simply heat total or total heat will be summation of these two, which is 0 0 8 plus 4 is 12, 8 plus 4 12, 1 plus 1 13, and this is 43200 or 43,200 joules. This is total heat value. Let's solve the second one. If each resistor has a power rating of 100 watt, determine whether it is safe to use these resistors in the circuit. To find the safe, it is whether it is safe to use or not. Power rating they have mentioned is how much? 100 watt. Let's find the power rating as per the current scenario. Okay, power for 6 ohms resistor, the power for 12 ohms resistor. So the power formulas what we have V into I, V square by R, and I square R. So which value we can use? We don't have current, but we have voltage and we have resistance. So simply I'll use the second formula, which is again V square by R. So voltage is 24 into 24 by resistor is 6, and in this case it is 24 into 24 and the resistor value is 12. So 6 4s are 24 and 12 2s are 24. So 24 4s 96 watt and this is 48 watt. So the power rating what they gave is 100. So definitely it is possible because 100 is greater than 96 and in this case 100 is greater than 48 watts. So the power rating of 100 watt is sufficient to maintain these power ratings 96 and 48. So you have to see yes, it is safe to use these resistors in the circuit. Okay, so in this way I am concluding the 5 marks questions from electricity chapter, and tomorrow mostly I'll see if it is possible or not, or else on Monday we'll connect back again and Monday we'll cover chemistry 2 marks. I mean the rest questions other than MCQs, which are questions are there, that will cover in the next video, and I will make sure to keep a video on Monday 1:30 p.m. if possible 1 p.m. as well. Okay, so in that video we are going to cover chemistry non-MCQ questions or other than MCQ, whichever questions are there. All questions will be covered in the next video, which will be on Monday, and if possible tomorrow or day after tomorrow we'll try to cover, or else by Monday 1:30 p.m. I'll definitely have it, or else on Monday evening. Okay, this time I'll make sure to change the time. On Monday 8 p.m. we'll have a live session. Okay, I'm changing it. On Monday 8 p.m. we'll have a live session on chemistry non-MCQ questions of the sample paper. Okay, so thanks for watching. Let's meet again on Monday.